SpaceX reduces the Raptor engine from thousands of parts down to a fraction of the original design. And it got more powerful, not less. What if the same principle could transform your code base? Most developers add complexity to solve problems. But I would say that the best engineers do exactly the opposite. And by the end of this video, you will understand the exact framework that Elon Musk uses to eliminate requirements and how to apply it to every system you build. If you look at pictures of the Raptor engine over time, something interesting happens. The early versions are full of parts. Different thickness, different materials, different elements. What does that mean? An endless amount of variables to tweak, to adjust, to control, to monitor. The latest version, it barely has any parts left. As a famous quote says, perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. And here is the key point. It did not got weaker, it got better. There's a theory in complex systems that explains this. Whenever you find a complex system working in nature, it usually comes from a very simple system iterated over and over again. We are seeing this in AI, for example, right now. The breakthroughs are not coming from clever algorithms. They are coming from simple algorithms fed with more data, trained with even more data. They just keep getting smarter. Unfortunately, the reverse does not work. If you design a very complex system up front and try to make it scale, it falls apart. Too much complexity is baked in from the start. Eventually, you have to remove things to make the system scale. Great product design is this process of iterating on your own designs until you find a simple thing that works and you remove the noise. The Raptor engine is a proof of that. So that leads to the question, how do you actually do this? Elon follows a specific sequence, and most engineers do it backwards. So, before you start optimizing a system, that actually is the last thing you should do, and before the efficiency part, you should start questioning the requirements. Why does this requirement exist in the first place? Not which department created it, but which person actually asked for it. Who's the responsible to coming up with that idea? Who said, this is the thing that I'm looking for? You go back to them and ask a simple question. Do you really need this? So first, we can eliminate the unnecessary requirements. And now you have fewer requirements to implement. Then you look at the parts and you remove as many as possible while still meeting what is actually necessary. Only after that do you think about optimization. And finally, maybe you will think about performance, cost, and scale. Most developers skip this straight to optimization. They try to make things fancy right away. They try to make the parts better when the real question is whether that part should exist in the first place. So here's a real example, a real story. Elon was trying to speed up the production of fiberglass mats on top of Tesla batteries. The line was slow, so they tried to optimize it. What he decided to do, one of the Elon things, putting a sleeping bag down in the factory floor and staying there until the problem was solved. At first, they tried to optimize the robot that was doing the process of gluing the mats to the batteries. And actually, they made it faster, but just a little bit. It was still too slow. Then he asked the question that no one was asking. Why are we putting these mats on the batteries at all? The battery team said it was for noise, so they sent him to the noise and vibration team to talk with them. That team said that there was no noise issue at all. They said it was actually for the heat in case of battery caught fire. So he went back to the battery team, but the battery team said there's no fire issue either here. So the conclusion was that that requirement was actually just dumb. It didn't make sense anymore nowadays. Each team was doing things based on the past, based on decisions from the past that they might not be true at all nowadays. So nobody was questioning whether this thing was still necessary. So they tested this hypothesis of skipping this requirement, they tested it, and no safety issue, no noise issue, nothing. So what they have done? they removed the part entirely. The line became faster almost instantaneously, and this happens all the time in complex systems. Requirements keep surviving long after their original reason to exist, and no one gets back to them to reevaluate the need. So now it's your time. Think about your code base. How many abstractions do you have? Because it is the way that is always been done. How many patterns exist because someone read a blog post 5 years ago? How many lines of code are there because an old framework bug that doesn't exist anymore was requiring those lines of code? When things get slow or painful, what we actually do is trying to optimize by adding a cache, by adding an abstraction, by adding more code, but that actually is making more complexity. This framework actually states the opposite. Before you optimize anything, trace the requirement back to its source. Ask if it still matters. Ask if you can subtract first instead of having. Later, you can optimize. The most important skill is not building complex systems. It is holding such complexity in your head with clarity, with transparency. System design is actually the skill. So remember this, complex systems that work almost always evolve from simple systems through iteration. The reverse rarely works. Before you optimize, question the requirements. Before you add parts, try to subtract them. Because the goal is not complex systems. The goal is the simplest system that solves the real problem. And one last thing, simple solutions are not the same as simple problems. And a lot of developers confuse those two. And I made a full video breaking down that distinction. And you can find it right here, and is the perfect video to watch after this one.